Hello geometers and general seekers of truth. In this video we are going to solve some problems with triangles and base angles and the base angles converse. So in this first example we are looking at a case where we have basically a word problem that describes a triangle. So usually the best way to approach this is to draw the triangle. So we know that two of the side lengths are going to be equal to each other. So let's make sure we cover that when we draw it. So here's roughly what this triangle is going to look like. This point up here is going to be x, this point down here will be y, and this here will be z. And from what we were given, we know that xy is equal to xz. We also know that angle x here is equal to 47 degrees. Now we want to know what is the measure of angle y. So to approach this problem, whenever we have an unknown, we can make some sort of variable. We already have x and y and z, so let's just call this angle here, I don't know, w. Okay. But because it's an isosceles triangle, we do know one thing is that these two angles down here, the base angles, are congruent. So if this angle here is w, I forgot the degree symbol. If it's w degrees, then this one over here must also be w degrees. And so now solving this problem shouldn't be too difficult. We know that the three angles add up to 180 degrees. So I have 47 plus w and w, so that's 2w is equal to 180 degrees. Subtract 47 from both sides and we get 2w is equal to 133. So w is equal to 133 over 2, or that would be 61, no, not 61, excuse me, 66.5 degrees. So let's see if we can correct that. Not 61, but rather 66.5 degrees. All right. So there you have it, just a very simple example of solving a problem that involves base angles. Now we're going to continue solving some slightly different problems, and in this case we have a triangle that we know nothing about except for some expressions. We know that it's an isosceles triangle, so one of the things that we can mark here, we can say that this angle here must be exactly equal, to this angle over here. So that tells us that 3x minus 11 must be equal to 2x plus 11. So add 11 to both sides and we get that 3x is equal to 2x plus 22. Subtract 2x from both sides and we get that x is equal to 22. Okay. Now this is a great start, but we also need to solve for y. Now in order to solve for y, we're going to take x and we're going to plug it back into our equation. So back into here, we know that this angle must be 3 times 22 minus 11. 3 times 22 is 66 minus 11, so that makes this 55 degrees. And because from what we said before, this angle and the angle that's opposite from it, in other words, the two base angles must be congruent, so this other one must also be 55 degrees. So to solve for y, we can say that 2y plus 55 and 55 is 110 is equal to 180. Subtract 110 from both sides and you get 70. Divide by 2 and we get that y is equal to 35. And so there you have it, a case where we're solving for the missing angles, the missing variables of a isosceles triangle. So there's another problem over here. You should really try this one on your own to make sure that you fully understand and are capable of solving these types of problems. Thank you for watching. As always, work hard and ask for help if you need it. Have a wonderful day.